You ever write a line of code, some simple math, and just assume Python knows what you mean? Well, it does, but probably not in the way you think. See, under the hood, Python follows a secret set of rules, a strict order for how it solves every single math problem. So today, we're going to pull back that curtain. Let's get into it.
And to really see why these rules are so important, we're going to start with a problem that looks incredibly simple, but this is right where the confusion can start.
Take a look at this. 3 times 2 plus 7. So how would you solve it? If you think about it for a second, you might see 2 totally different ways to get an answer. And that's the whole problem right there.
I mean, if you decide to add first, right? You get 2 plus 7, that's 9. 3 times 9, boom, 27. But what if you multiply first? Well, 3 times 2 is 6, and 6 plus 7 is 13. We've got 2 completely different answers from the exact same expression. And this is the whole issue, isn't it? We can sit here and debate which way is right. But a computer can't do that. It can't be ambiguous. It needs one single repeatable answer every time. So it has to have a rule book to tell it which path to take. The question is, how does it choose?
Well, it chooses by following something called the order of operations. This is the official set of rules that Python uses to get the one correct answer, every single time with zero confusion.
Now, the formal name for this is operator precedence. And really, that's just a fancy way of saying there's a strict hierarchy, a pecking order, that decides which math operators, like multiplication or addition, get to go first. This totally eliminates the guesswork.
And this hierarchy probably rings a bell from your old math classes. It's PEMDAS. You know it. Parentheses first, then exponents. After that comes multiplication and division. They're on the same level, so you just go left to right. And last, you have addition and subtraction. Again, evaluated left to right. This is the exact roadmap Python follows.
Okay, theory is great and all, but let's actually see how this plays out inside a Python script. This is where those rules really come to life.
So for our examples, we're just going to use these 4 variables to keep things clear. We've got A as 2, B as 3, C as 5, and D as 7. Just keep those numbers in the back of your mind.
All right, first up, A times B plus C. Now, the second you see this, your eyes should go straight to one thing, those parentheses. They are the VIPs of this expression.
Remember PEMDAS? That P for parentheses is king. It comes first no matter what else is going on. So Python immediately dives in, solves B plus C, that's 3 plus 5, to get 8. And just like that, the problem simplifies to 2 to the power of 8.
And 2 to the power of 8 gives us our clean final answer, 256. See? No confusion, no debate, just one answer, all thanks to that first rule.
Let's try another one. This time, we've got A times B to the power C. Notice, no parentheses here. So now we've got a showdown. Does multiplication go first, or does the exponent?
Well, if we check our PEMDAS rulebook, E for exponents comes way before M for multiplication. So Python calculates B squared C, or 3 to the 5, before it does anything else. That gives us 243. Only then does it look at the multiplication, turning the problem into 2 times 243.
And that leaves us with a final answer of 486. This is a perfect example of how the order matters. If you had just gone left to right, you would have gotten a totally different and wrong answer.
All right, one last standard example. We're mixing it all up this time. A plus B times C divided by D. We've got addition, multiplication, and division all hanging out in the same line. What's the plan?
So in PEMDAS, multiplication and division are partners. They're on the same level of importance, and they both come before addition. Python groups that hold B times C divided by D part together. It does 3 times 5 to get 15, then it divides by 7. That poor little A at the beginning just has to wait its turn. And after all that's done, Python finally adds the 2, and that gives us this long floating point number, a super precise result, all because Python followed that order of operations perfectly. So the rules seem pretty simple, right? Parentheses, exponents, multiply and divide, add and subtract. You follow the list, you get the right answer. But let's look at a fascinating edge case where the predictable world of math gets a little weird. We already know that multiplication and division are on the same level. Python's rule is just to work from left to right. But here's the thought. Does it actually matter? If we rearrange them, would it ever change the answer? Look at this. If we do 300 divided by 300 times 200, we get 200. If we swap it and do 300 times 200 divided by 300, we still get 200.
Mathematically, this totally makes sense. The order doesn't seem to matter one bit.
So you might think, okay, case closed. Order doesn't matter for partners. But this is where the pure world of math collides with the physical limits of a computer. What happens if we use numbers that are just ridiculously, mind-bogglingly big?
Check this out. On the left, 1e300 divided by 1e300 is just 1. Then, 1 times 1e200 is, well, it's a huge number, but it's a valid number. But look at what happens on the right. When we try to multiply first, the result of 1e300 times 1e200 is a number so astronomically huge that a standard computer number type literally can't store it. It overflows. And Python's response is to just call it infinity. Once you have infinity, dividing it by anything still leaves you with infinity. Same numbers, same operators, but a different order gives us a totally different result.
And that really leaves us with a fascinating final thought. We depend on these rules to be absolute, but sometimes the very hardware we're running on can introduce these bizarre little quirks. Makes you wonder, doesn't it? What other hidden rules and surprising behaviors are just waiting to be discovered in the code you write every day?